Let's be honest, we are drowning in plastic. But what if we could take one of the absolute worst offenders, the stuff that's practically impossible to recycle, and actually transform it into something valuable? Well, today we're diving into a really cool scientific breakthrough that does exactly that, turning plastic trash into chemical gold. Okay, so this is the blueprint for how it all happens. And yeah, I know it looks like a super complex chemistry diagram because, well, it is. But the big idea behind it is actually pretty simple. And to really get how it works and why it's such a massive deal, we first have to talk about the specific plastic that's at the heart of the problem. So why is this innovation so crucial right now? It really all comes down to one very specific and very, very stubborn type of plastic: polystyrene. And the scale of this problem is staggering. I mean, look at this. In some waste streams, polystyrene makes up more than half of all the plastic. Just think about that. We're talking about all those takeout containers, the lids on your coffee cups, the styrofoam packaging that protects your new TV. It is absolutely everywhere. But here's the real kicker. Even though it's everywhere, polystyrene is notoriously difficult to recycle with our current methods. It's super lightweight, it's bulky, and it's usually got food all over it. And that means the vast majority of it just ends up in a landfill or worse, floating around in our oceans for hundreds of years. So, how do you even begin to solve such a huge problem? Well, as it turns out, the answer is something incredibly small. It's time to meet the hero of our story, a revolutionary new catalyst that is a total game changer. So what is this tiny hero? It's called a single-atom catalyst. And honestly, the best way to think about it is like a microscopic, super-efficient matchmaker for molecules. Instead of using big clumps of metal to get a reaction going, this technique uses individual, scattered atoms, in this case, ruthenium. And that gives it this unbelievable precision, wasting almost nothing. And we have to give a huge shout-out where it's due. This brilliant breakthrough comes from a team of researchers at Nanjing Forestry University and Tsinghua University. They're the ones who engineered this tiny, elegant solution to our massive plastic problem. All right, so we get the problem, and we've met the tiny solution. So how does this catalyst actually turn all that plastic trash into treasure? Well, it's a pretty fascinating two-step journey that all happens inside a special reactor. Okay, here's how it works in a nutshell. First, they take all that solid polystyrene waste and they cook it. I mean, they really cook it to a blistering 475 degrees Celsius. This is called pyrolysis, and it basically just unzips the long plastic molecules, turning the solid into a gas. Then, that hot gas gets passed over our single-atom catalyst, and this is where the real magic happens. The catalyst gets to work, precisely rearranging all those gas molecules and turning them into a really valuable chemical called toluene. So we know it works, but the real question is, how well does it work? This is where the story gets really exciting. Let's look at the numbers, because they show just how big of a breakthrough this truly is. Just look at that, over 99% conversion. That means for every bit of polystyrene you feed into this thing, basically all of it gets transformed into something new. There's almost zero waste left over from the process itself. That is just insanely efficient. And it's not just efficient, it's also incredibly precise. This number, 83.5%, is what they call selectivity. It means that most of the stuff coming out is that one single thing they want to make, toluene. It's not creating some messy chemical soup. It's like a targeted chemical factory.
And why toluene? Because this stuff is valuable. It's a key ingredient for making industrial solvents, paints, glues, all sorts of things. And this is what makes the whole thing a game changer. You're not just getting rid of waste, you're creating a product that has real market value. You're literally turning a disposal cost into a revenue stream.
And on top of all the economics, there's a huge environmental win here. This process isn't just profitable, it's way better for the planet. Its carbon footprint is nearly half that of the traditional way of making this chemical. So you can tackle plastic pollution and lower greenhouse gas emissions at the exact same time. It's a true win-win.
So let's just zoom out for a second. What does an innovation like this really mean for the bigger picture? Because this is about way more than just one type of plastic. This is about completely rethinking our entire relationship with waste.
What this does is fundamentally shift us away from that old linear model of take, make, and waste. Where polystyrene is just trash at the end of its life. And it moves us to a circular one. It's about transforming something that has a negative value, a pollutant, into something with a positive value, a useful raw material.
And that right there,
That's the whole idea behind the circular economy. It's about designing systems where there's really no such thing as waste. Every output just becomes an input for something else. Waste streams become value streams. And this technology is a perfect, powerful example of that idea in action.
Which brings us to a final, really big thought. Technologies like this that use advanced chemistry to upcycle waste into high-value stuff, that's a giant leap beyond just, melting down bottles. So the question we're left with is this: are we looking at the actual future of recycling? A future where our trash truly does become our